All right, so we're gonna go ahead and start this class today for our beginning of the final week of cryptography. Before I go into this week's assignment, I'm gonna go over that LFSR cipher because I did goof up and show you guys the wrong line of code to get there. So I'm going to go through how to do that without any imports, just basic Python. Just as a reminder, I have this screen up again from class 2 weeks ago. This was, last week. This was the abstract, how I just talked about making the key stream, which is the most difficult part of the LFSR cipher. Talked about making the key stream and how you have these rules, your initial seed up here, and how everything carries down to your key stream over here and it generates and all that sort of stuff. And I just wanted to go through real quick. I'm just going to quickly talk about it. Basically, every row inherits the property of the row next to it and above it. So it looks to whatever the previous number was, and it copies it. And then this final row has a rule right here, and it does to check using the some other two instances. There are different rules and there are different seeds, but there are even different lengths of seeds. But for right now, this is just the example that I'm going to go through, and I can change it in the code to show you how you would do that. What's up? Says my stream is paused. Okay. We'll go ahead and just, how about that? Is that better? All right. So, I'm just gonna quickly run through that one more time. We have our key stream here, which is generated from these other rows, and every little row here looks to the previous column and just inherits that value. Our final row on the left here has some sort of rule that it follows that's a little bit more complex than just looking to a neighbor. In this case, it is the XOR of B2 and B1. You can have a different rule with different length of seeds and that sort of stuff, but this will be our example for now, and I can show you how to change that in the code. All right, for our code here, we still have our same text clean function that we've been using this whole time. I'm just going to go ahead and hide that. We still have our same binary convert that we've been using that turns our binary, and this one, our text to a 5-character string of binary. We have our text convert, which is the other thing, and other way around, takes our 5 string of binary and converts it to a letter. And then we have our just our XOR function from the first week using the binary stuff, and here is our LFSR cipher. So what was a little bit different, I won't go into how you would do the NumPy stream for it, but I will go ahead and show what it would look like for the default Python. So first thing we're going to do is, I didn't show you guys this on the last meet, but you're going to want to take your seed of each position and you want to use this int or int. That basically says turn this into an integer, which is in this case whatever our character for the binary is. So the seed of the 1 position, 0, which is 0 in Python, stream seed of the 1 position, 2 position, 3 position, and we want to make sure that it's an integer, because right now our seed is, if you look down here, a string. It's in quotation marks. But we want it to be a number that we can use a function with. So, like I said, our most difficult part of this is creating the key stream. So I will go ahead and walk through the creation of that using this code. I'm just going to quickly notify the students that Discord has actually crashed, so it is all online. All right. So first thing we do, just like we did for other ciphers, is we have our key stream that is this open string. We just have our two empty quotation marks. You can have them these two, or you can have it these two. It doesn't really matter. They both do the same thing. For this, I used a while loop. You could use a for loop. Use it by saying, while length of key, or sorry, for, the I in the length of key stream, but it's just a little simpler if you just use a while loop, which basically is another Boolean condition loop that's saying while the length of the key stream is less than 5 times the length of the text, which, remember, the length of the text is going to be multiplied by 5 because that's the binary amount is on the 5 characters. First thing it does is for the key stream, it takes plus equal the B1. If you remember up here, and if we look over here, this first part of the seed, B1, is their first character in the key stream. And then every time this goes through the loop while this condition is met, it'll go back to the top and it'll add B1. So the next time B1 is 1, then the key stream will add a 1 to it, then a 0, then a 1, then a 0. And that's just for this example. Now I have these second group. Also, make sure that you have a string because our key stream here is an open string, whereas our B1 here is an integer. So I'm going to just make it a string. Basically what that's saying is turning our 1, in this case, into a quotations 1. If you remember, the caret is the XOR function. What this function up here does is to make XOR while it is in a string, but whenever you have integers, you can just use this caret like that, easy peasy. And basically what we do is we find what our new B4 is. Basically, we're given this row. We're trying to figure out what this row is by saying this is the new row. A little bit different from this, which is saying the current and the old. You're using the current, or using the old to find the current. This one we're using the current to find the new. But it still works out. We're taking our B4, this is our rule is the B1 XOR B2, and then that becomes our B4. Our new B3 is equal to whatever our previous B4 was. New B2 was the previous B3. The new B1 was the previous B2. And then, if you remember here, it doesn't just have these two rows. That was a big problem. I was trying to replicate this code. It actually took me a fairly long time before I came up with this to actually get it so that it goes on and continues. We want to set our B4, what our current B4 is, to the new one, right? So after we've done our calculation here, this may look like it's just sort of backwards, but we want to remember it goes through the loop, determines what the character is on the key stream, finds what it'll be on the next row, and then this is essentially saying, all right, now we're going to set that next row to the current one. Then it's fairly simple. I just do have the binary conversion, which remember is up here. It converts our text to a binary. Binary conversion is the XOR using this function, because we're now using strings again, of our key stream, which was determined in here, and our binary stream, which was used during the binary convert text at the beginning. Once it'll XOR each of the ones and each of the zeros at the appropriate place, that'll give us this term binary conversion. What we want to return is that binary conversion, but we want to convert it into a text, because if you remember, I said to put in a text, use binary for the calculation, and then return another text. So now we can see what I've got here. Our cipher here, if we say boy with that same seed that we were using, it is our exclamation point Q question mark. What I'm going to go through here and do real fast is, just so you can see, I want to print the key stream for you, just so you can kind of know what it is. So, what I'll also do, there's our key stream. We're going to print our binary stream. This is what our text is. And then what it does is it just XORs these rows here, puts them in together. Remember, XOR is the addition form for binary. 2 zeros is a 0, 1 0 is a 1, 1 1 is a 0. And then what this final thing does is it converts that back into a plain text, a readable English alphabet with the additional characters that are down here on the bottom. So let's just, if we can try another word. We'll say YTAC is our word. We'll try another seed. For this, though, it has to be 4 characters because we've only specified positions 0 through 4. If I did, I'll just go ahead and run this. You see it's period, parenthesis, PA. If I added more here, it wouldn't change because we haven't given a variable to seeds positioning 4 and above. So this really only is effective during that. If we wanted to change that, we could go through and add a B5, a B6, or whatever. But I'll just stick to a B4 length key seed. Now let's just say, for example, that we want to change what the function is. Remember B3, B2, B1, these rows will all follow the same rule of just look to the left and find that one. But our B4 is the function, but let's say it does instead B1 and B2 and B3. And then if we run that, it's a little bit different. If we just said B1 and B3, it's a little bit different again. So this one, you could have a variable that is your rule variable. But honestly, as these get more complex, it's just easier to go in here and quickly change the number corresponding with the B. So back to our period parenthesis PA. I'm sorry for the confusion on this one. That's my bad. But that is going to be the last that I teach you of cryptography. I'll go into what we're doing next after I tell you what the assignment is for this week. Now, what we're going to do is, if you look in the Discord, I'll go ahead and pull it up here on the screen. You can see this big NCSSM, North Carolina School of Science and Math, cryptography book. And this textbook is what I've been teaching through. You can see as we go into it, we can click over here and say, it gives a definition on like loops and different ciphers that were in here. Our substitution message, we can say, oh, look, here's the explanation of the Caesar cipher. We're all the way down here with the chapter 10 LFSR stream. Well, we're just on the linear feedback shift register stream cipher, but we can also go to LFSR sum and so on and so forth. And this will give you the definitions for all the stuff, including RSA, KID RSA, these additional ciphers that were in here. Not only are there ciphers, but there is also, see if I can find it in here. Yes, here it are, some different tests. Here is a test, the Kasiski test, and that has this isn't a cipher, this is a test. If we look down here, if we look in the cryptanalysis, we can see these are some terms that aren't ciphers. We have brute force. This is what I was telling you about earlier in the class, where you can just print everything and try and go through. And then if we look at these, and then we can kind of see where is the proper plain English. Here it is. If he had anything confidential to say, ... he wrote it in cipher. So then You can make a brute force for another cipher. You could do frequency analysis, and this is basically saying uh, it's a little bit different. Frequency analysis is looking at the frequency, how often a letter appears in the alphabet, and in the plain text and in the ciphertext. So you can use these graphs to tell. So if you're doing like a shift plot, right? This is regular English that you have here. You have your E is the most present letter. T is also very close, and A is very close. And then you can see that this is a shift cipher. If you look, it still has a very similar shape. It's just kind of scooted over. So you can kind of tell, okay, this is E, here's D, C, B, A. That's what I look for first, this little pattern of 5 letters going right here. And then you can say, well, this is probably T, so you can just count. So A, it went from A to H. So 1, 2, 3, 4, 5, 6, 7. So it shifted 7. And then that was, I guess you see down here is what that's basically saying. You could determine that your key is 7. You would have to import a plot function to get this. But that's just another another like sequence that's in here, and another part of this textbook that I did not cover. You can see the solving congruences, chi-squared, not chi-squared, chi-squared scoring, and going through this stuff. And here we have a funny meme that some middle-aged white people at the North Carolina School of Science and Math thought was funny. So we are going to, well, what I'm going to say is for your week's assignment, you have to go through this book and find something that I did not cover and program it. Frequency analysis is a very easy one. Brute force for a different cipher. You already did a brute force for a Caesar, so you couldn't just replicate this. Or going through, if you wanted to really get my respect, you could learn the RSA cipher. You can do anything in here that we haven't covered as well. It doesn't have to only use this book as a reference. You can look up YouTube videos on how the ciphers work. You can look up how other people have programmed it. But limitation being, I don't want you to import somebody else's just usage of this cipher. I want you to write the code yourself. For that, importing is okay for the frequency analysis because you can't make a graph without that. But for the example of our ciphers, you can, all over the internet, someone has an RSA cipher, and then you could just say import RSA and then just do that. So that won't work. You have to actually create the code yourself. So that's really all that I have for this week. It is a shorter week, hopefully very simple. So, also, quick thing here, there are some other ciphers. These ciphers are more conceptual and similar to that LFSR cipher. You can see here this GIF that shows what this rail fence cipher is and how that works with this 2-row separation. So if you wanted to do this, you could. But shorter week this time. I just want you to figure out how you're going to program a cipher or a fundamental theory of your choosing, and then that will wrap up our cryptography unit. After this, we are going to be starting on the 31st during the cohort 3. We're going to be starting programming on Arduino. So if you are interested, there are two options for you, really. You can get your own Arduino starter kit right here. Shopping, as you can see, if you get the on-brand starter kit, it is about $82. You can snag some deals on eBay for much less. You could also get some off-brand stuff, and off-brand things are pennies for all of your components. But you're going to want to get the Arduino Uno, and we're going to be walking through some functions that one of the creators of Arduino, Massimo Banzi, he made a project book, and we're going to be walking through that project book. You can kind of see it. I think this book on top there is one of the books that they have that we're going to be going through. You can buy this, but at the very start, what I will be using is Tinkercad. Tinkercad has a very good Arduino simulation that you can use. It falls a little short with some of the sensors, like for a light sensor, for instance. You just kind of have a slider that indicates how much light. So that's a little bit different than if you had an actual light sensor. But either way, you can send videos for that as well. That'll be fine. Like, you take a picture with your phone and then you get your code. Arduino does not use Python code, so if you are just now hopping in on the Python grind, I don't want to say forget what you heard rather, but don't stress too much about learning it. Arduino uses its own particle board code that it does, and I will walk through that as well as with Massimo Banzi. But that is what we have coming up. What we're hoping for is, once Arduino coding lessons have advanced a little bit from just the first week with the however many people we get with YTAC. After that, we are going to think about maybe YTAC sending out starter kits to people interested and devoted, and then we can get some actual hands-on, because part of what makes Arduino so interesting, so successful, and so useful is the hands-on experience on top of the coding experience. So you have to build your circuit, you have to put the sensors in the right place, and then you have something that interacts with the real world. Which is, if you want to look at some great examples of applications of Arduino, you can check out Mark Rober's YouTube channel. Very large science and engineering YouTube channel where he does have some good uses of mechanics, as well as Arduinos for sensors, as well as servos and actions and various stuff like that. Again, that's Mark Rober. And you can see here it's this gentleman right here. Very good resource. You can see not all of this stuff has particle board, but there is a fair amount that is very useful, and if nothing else, it's a very entertaining channel. So that is all for this week. Thanks for watching. If you have any questions, as always, feel free to DM me. And good luck with your looking through this book. I will re-link this textbook into the Discord channel, as well as I'll put this our LFSR cipher in there as well, in case you wanted to see how different yours was. But for now, that's all. Thanks.